Hello guys, welcome to the chemistry revision, and this I think is the last revision that we are going to do on the topic organic chemistry, so that we go to the next topic, which is nanometals. Okay, so without further ado, let's go straight into this revision. We have question 19, which came from section A. So the question reads: the following structures represent different types of soap. The following structures represent different types of soap. So we have this different type of a soap. This is a different type of a soap, and this is another different type of a soap. Then the question says, which statement about soap is correct? Soap is A base, B, an ester, then C, a polymer, then D, a salt. So the answer is D. So soap in its sense is actually a salt because it is made from a carboxylic acid and a metal. So when you look here, this is part of a carboxylic acid. Okay, so you'd find that it is made of organic acids, I mean, like fatty acids, like this part here, and then you add like a metal here. So this is a different type of a molecule, a different type of a molecule, a different type of a molecule, but they have this common structure here. So when you get like a base, then you react it with some fats, then you make soap. You are basically making a soap. So soap is actually a salt. So we go to another question, which is question 20. It says, what would be the structure of the polymer formed when the following monomers undergo polymerization? What would be the structure of the polymer formed when the following monomers undergo polymerization? So we have this monomer here, which has a COOH functional group. This is the carboxyl. So this is a dicarboxylic acid. And we have this another monomer which has OH, which is hydroxyl groups. This is a hydroxyl and this is a hydroxyl, and such a monomer is a diol. Okay, it is a monomer of alcohol actually with the two carboxyl at the both ends. So now the question says, what would be the structure of the polymer formed when the following monomers undergo polymerization? Okay, so this is a dicarboxylic acid and this one is a, a diol. So what will happen is that a diol is going to lose one hydrogen, while this one will lose the hydrogen and the oxygen. So they end up forming a functional, or rather a link, which is an ester link. So an ester link is COO, like this one here, COO, and this one COO. So the polymer which is going to be formed is between C and D, but these are supposed to be different. So the question, of course, wasn't really phrased properly in my case. The question was not made properly because this and this, they look the same. This is when I'm realizing it. They're supposed to be different, these shapes different. So this one, if it loses this one, it remains with this one remains with that. So the other side, it has lost this side here. So it will remain with the OH if these ends are used. Okay, if these ends are used, this one will lose OH. It can remain with the CO. So we discarded these. We are only dealing with these. Of course, both are looking the same here, except I want to rule out these parts because they used both similar. So now I want to know which one is correct, whether I was wrong or not, because in my answering, the answer was actually this one here, because they are not supposed to be the same. Now, I'm trying now to analyze properly what happens when both ends are used as joining points. So if this one loses OH, it will remain with CO. If this one loses this side H, it will remain with just O. So meaning this one is wrong. The correct answer is this one. So this one is wrong, but from the setup itself, the setup is the one which they didn't do well. They should have differentiated them there. So this one, if it loses the oxygen there, then it will definitely have O here. So this one is this one, then this one is this one. So if it loses OH, it will remain with the CO, then this one will bring the O here. Then if it lost the H here to remain with the O, this one, if it lost the OH, it will remain with the CO here. So that's what happens. So this is why this is wrong, because it is suggesting that this one will also have like O, CO, and this one as though it is the same one. No. So we go to the next question, which is 8. This question says the 4 hydrocarbons given are members of a homologous series. The 4 hydrocarbons given are members of a homologous series. So we have CH4, C4H10, then C6H14, and C10H22. Then A says explain the term hydrocarbon. So hydrocarbon just means a compound whose molecules contain only carbon and hydrogen atoms. So like it is here, if you cut it here, you find that it has two. This side it is hydrogen, this side it is carbon. So altogether hydrocarbon are just compounds that contain only carbon and hydrogen atoms. Okay, then we come to B. B says name Roman numeral 1 homologous series. Name the Roman numeral 1 homologous series to which the above hydrocarbons belong. So the hydrocarbons which contains only C and H, and then they begin with a hydrocarbon with C1 with one carbon here. These are alkanes. So quickly you identify them, because with alkenes you can never have a member which has one carbon. Why? Because in alkenes, for you to have an alkene, there must be at least a double bond in an alkene structure. In each member of an alkene, it must have a double bond between carbon atoms. Now, if you have just one carbon atom here, how can you have double bond? Not possible. So alkenes, like alkynes, they'll have a double bond, but alkanes, they'll never have a double bond between carbon atoms. And that's why they start with a member with one carbon atom. Like this is methane, this is butane, this is hexane, this is decane. So if they say name the homologous series to which the above hydrocarbons belong, it is alkanes. Then Roman numeral 2 says compound. Name the compound with the molecular formula C4H10. So this one, which is C4H10. So remember, the number of carbon atoms are used to name. In the previous video, I said if you have like one carbon, it means meth. Two carbon, it means eth. Then 3 carbon prop, then 4 but, then 5 pent, then 6 hex, then 7 hept, then 8 oct, then 9 non, then 10 dec. Okay, so that's how I came to know this is 1 carbon meth, 4 carbon butane, then this is 6 carbon hexane, 10 carbons decane. Now if they say we name the compound with the molecular formula C10H10, so C4 it means butane. So this one is butane. So we go to the next question C, which says draw the full structural formula of the hydrocarbon which has 4 carbon atoms. So the hydrocarbon which has 4 carbon atoms, now it's the same one, butane, here we are dealing with. So the structural formula will be this one here, but I'm sure this one is called the full structural formula. Yeah, displayed structural formula or structural formula, but usually this one is displayed structural formula, but in this case I think it is the same one they are asking for. But in some cases this is how they name them, if I'm not mistaken, with the language, because in Zambia they like making mistakes with languages. So maybe food structural formula they meant displayed. So otherwise sometimes you do it like this: CH3. Then if you want, you can connect here like C123 hydrogen. Then this one is, you say CH2, okay, like C, this one, H2. Then again you put again CH2, then CH3. Yeah. If not this one, then it is this one. But I'm sure, according to Zambian context, that's what they mean. Then we move to D. Which of the given hydrocarbons has the highest boiling point? So with those they gave us, let me just get back. These they gave us. The one with the more carbon atoms is the one with the highest boiling point. So in our answering, which of the given hydrocarbons has the highest boiling point? It is this one here, C10H2. It has the longest carbon chain, so the longest London forces. So London forces are the forces in the molecule, which makes it to have high boiling point. Then we go to the next question, which was C3. C3 says propene is one of the main important hydrocarbons obtained from crude oil. Like propane, it is made up of molecules which contain 3 carbon atoms. Then A, we are saying 1, draw a structural formula for propene. 2, how does propene differ from propane in terms of bonds? Then 3, to which group of hydrocarbons does propene belong? 4, give the molecular formula for propane and propene respectively. Then B, Roman numeral 1, explain why propene reacts immediately with bromine water, whereas propane does not. Then 2, describe what would be observed during the reaction. Then C, propene is obtained by breaking down longer chains of hydrocarbons. Then they're saying, what is this process called? Then D, propene is a monomer for making an important plastic. Take the name of the polymer it forms. So we'll start answering. So we'll start with A, Roman numeral 1, draw a structural formula for propene. So we'll draw it like this. So propene has, propene, it means the 3 carbon atoms. So 1, 2, 3. Between the carbon atoms, put a double bond and surround each carbon atom with 4 bonds, like 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then distribute the hydrogen atoms like that. Then Roman numeral 2 says, how does propene differ from propane in terms of bonds? You say propene has 1 carbon to carbon double bond. Propane has only single carbon to carbon bonds. So yeah, that's how propane and propene differ from each other. In propene, at least there's a double bond between 2 carbon atoms, while in propane there are single atoms between carbon atoms. Then we go to the next question, which is a question, um, um, which is question to which group of hydrocarbon? Okay, So this should be question 3. To which group of hydrocarbons does propene belong? So in answering the same, alkenes, because propene is an alkene. Then they're saying give the molecular formula for propane and propene respectively. So we'll give for propane it is C3H8, propene it is C3H6. Okay? Why is it that? Because these are alkanes. So alkanes, remember the general formula we looked at was CnH2n plus 2, which means when you are talking of propene, you say prop means n is equal to 3. So if you say C3, then you say 2 times 3, it will be 6 plus 2, it will be H8 now. Okay, so this is how we got this one. Then propene, the same, and it is an alkene. So alkenes, the general formula is CN, then 2N. So the same prop, but if you put 3, it will be C3. Then here we'll say 2 times 3, there 6, so it will be H6. This is how we arrived at this, okay? So just in case you are wondering, that's what I've explained. Then we move to the next question, which is B, okay? So B1 says explain why propene reacts immediately with the bromine water, whereas propane does not. So in answering or same, because propene has one double bond between two carbon atoms, which allows it to undergo additional reaction with bromine, while propane does not undergo additional reaction with bromine due to lack of double bond between carbon atoms. Yeah. Then 2 says describe what would be observed during the reaction. So when propene is reacted with bromine water, what would be observed during the reaction? So we are saying when propene is added to bromine water, the orange or brown color of bromine water disappears or becomes colorless. This is a positive test for unsaturated, okay, or unsaturation. Yeah. So that's what it is. So these, like alkenes, are known to be unsaturated, while alkanes are known to be saturated. In case they say, what does it mean to be? They can put a question like, alkenes are referred to as unsaturated hydrocarbon. What do they mean by an unsaturated hydrocarbon? So in answering, you can say these are hydrocarbon with a double bond between two carbon atoms. Okay, you can just put it in that way, it is correct, or you can say these are hydrocarbons which are reactive due to a double bond between carbon atoms. So the test which is there to identify whether a hydrocarbon is unsaturated or not is by reacting a hydrocarbon with the actually bromine. So if a hydrocarbon decolonizes bromine, then it is referred to be unsaturated. So this is how we identify, okay? So this is how we identify. So that's why I stated this is a positive test for unsaturation. So we move to the next question, which is C. C says propene is obtained by breaking down longer chains of hydrocarbons. What is this process called? Okay, so answer, propene is obtained by breaking down longer chains of hydrocarbons. What is this process called? So we are going to say this process is called cracking, specifically the breaking of long chain hydrocarbons into shorter, more useful hydrocarbons. Yeah, that's what it is when you propene is obtained by breaking down longer chains of hydrocarbons. What is this process called? This process is called the cracking. Then D, propene is a monomer for making an important plastic. State the name of the polymer it forms. So propene, when it is joined to form a polymer, the polymer will be polypropene. So in answering, we'll say propene forms polypropene, also known as polypropylene. So that is the name of the monomer. Then we move to question 18. An unsaturated hydrocarbon with 6 carbon atoms contains only 3 double bond carbon to carbon double bonds. This hydrocarbon is reacted with excess hydrogen at high temperature. What is the formula of the resulting hydrocarbon? Okay, so we are told that there is unsaturated hydrocarbon. So if it is unsaturated, we expect it to be an alkene because they've told us that it has 3 carbon to carbon double bonds. So let us just see draw its structural formula. So remember the general formula is CnH2n. Now if it has 6 carbon atoms, it means N is equal to 6. So this is hexane. So say we'll put here 6, it will be NC6. Then here we'll also put 6. So 2 times 6, it will be 12. So it will be H12 here. So now they are saying this hydrocarbon, meaning this one, is reacted with excess hydrogen at high temperature. So it is reacted with excess hydrogen, meaning plus hydrogen. So this one should be hydrogen gas. So now what happens is that those bonds, one of those bonds which it has here, break down to add more hydrogen. So it will be C6H, then to these 12 hydrogen you add 2, so there will be now 14. So when they say what is the formula of the resulting hydrocarbon, it should be like this. So in our answer, you see that our answer is what? Is C. The 19, the reactions listed all involve ethanol. The reactions listed all involve ethanol. So all these reactions, 1, 2, 3, involve ethanol. Oxygen gives us this is ethanoic acid plus water. Then to ethanol plus ethanoic acid gives us ethyl ethanoate plus water. And this one 3 ethanol turns into this one is glucose turns into ethanol plus carbon dioxide. Then they're saying which row correctly describes each reaction. Like which row here, these rows um, define or describes each reaction correctly. So let's identify one. Let's start with one. If you have ethanol and oxygen, ethanol with oxygen, this is oxidation reaction. Then ethanol with carboxylic acid, this is esterification. Okay. Then this is glucose into ethanol and carbon dioxide. This is fermentation. So now, if they say which row correctly describes each reaction, we know that number one should be oxidation. So we check. So it is either C and D. Then number 2 is esterification. So which one? It is D. So here we know that 2 are correct. So 3 is in fermentation. So the answer is D there, you see. Then we go to 20, study the following organic compound. So this organic compound here, because it has a double bond here, it is an alkene. Okay, so we know already that it is an alkene. Then the question says, why is the compound shown? Why is the compound shown able to decolorize the bromine solution? It A can dissolve in a bromine solution. No. B has double bond between carbon to carbon. Yes. So our answer here is supposed to be our answer is B. Then we move to the next question. Question 9b says the following diagram shows sum of the reactions of ethanol. So ethanol is at the center, reacts, complete combustion gives us a gas. So when the ethanol reacts and gives us a gas and water, gas plus water, that gas R is carbon dioxide. That's how it is. And this is actually water. Then they're telling us that ethanol undergoes process process Q to form ethene. This is the dehydration, like you are removing a water molecule from it. Then if ethanol changes to solution P, it is oxidation, okay? That is correct. Then oxidation give us solution P. So solution P, when ethanol undergoes oxidation, it forms an acid. Okay, so this is ethanoic acid. So solution P will be now ethanoic acid. Okay, so yeah, so now they are saying draw the structural formula of ethene. So it will be like this, ethene. Then we'll move to the next question, which is question B. They are saying give the names for Roman numeral 1 solution P. So solution P, we already said that it is ethanoic acid. Okay. Then process Q. Process Q, we said dehydration. Then gas R, we said the carbon dioxide. Okay. So process P ethanoic acid, process Q dehydration, then gas R, which is carbon dioxide. Then C, they're saying write a balanced chemical equation for the complete combustion of ethanol. So this is the balanced. So ethanol plus C, oxygen gives us C, carbon dioxide plus water. This is the balanced equation. Okay. Then we move on to C3. It said ethanol is a product of many fermentation reactions. The molecular formula of ethanol is this one here. Then they're saying A, draw the displayed molecular structure of ethanol. Then B, when ethanol is heated with potassium dichromate 4, it is converted to ethanoic acid. 1, what type of reaction in this? Then 2, give one safety rule to be observed when handling ethanoic acid in the laboratory. Then C, ethanoic acid reacts with ethanol in the presence of a catalyst to produce a new substance. Then give the name and deduce the formula of the new substance. Then D, ethanoic acid is weak acid. It can react with metals such as sodium and magnesium to liberate hydrogen gas. Compare the rate. Okay, these I did not answer them because they are not from organic now. They have mixed now with the acid and rate of chemical reaction. So I only answer these here. So let's start with A, which says draw the displayed molecular formula of ethanol. So this is the displayed molecular formula of ethanol. It should have 2 carbon atoms, but if you cannot remember how to do it, you just remember the structural formula for alcohol. Remember we said the general formula, which is CnH. You said 2n plus 1, then OH. So if they say ethanol, you just know that eth means N is equal to 2. So you just say C, then you put what? 2 here, then H, here you have 2, then you say times C, where there is N again you put 2, plus the 1, then you put the OH, then you complete C2, then H, you say 2 times 2, 4, plus 1, 5, then you bring the OH there. So you find that this is the formula for ethanol. Oh, they already gave it there. Okay. So now to just write a structural formula, you just put the carbon like C. You scatter these two. You scatter them like this. Then you can add even like OH. OH. Here OH, you can even put it like that. Then distribute these hydrogen. So you surround each carbon with 4 bonds. So this carbon has 1, 2, 1, 2, 3, 4. This carbon has already 1, 2, then 3, 4. So you distribute this hydrogen everywhere. 1, 2, 3, 4, 5. So you see, this is how that was arrived at, and that's how you can do it. Okay. So we move to B. B has this question. They're saying when ethanol is heated with potassium dichromate 4, it is converted to 1. It is converted to ethanoic acid. 1. What type of reaction is this? So this reaction is oxidation. Okay. Then 2. Give one safety rule to be observed when handling ethanoic acid in the laboratory. Okay. So we can say that wear goggles because ethanoic acid is corrosive. So you wear goggles because it is corrosive, it is an acid. Then we move to the next question. So let's push here. The last question says, C. Ethanoic acid reacts with ethanol in the presence of a catalyst to produce a new substance. Give the name and deduce the formula of the new substance. Remember, if you have ethanoic acid and ethanol, this reaction is an esterification reaction and it gives ethyl ethanoate, which is an ester. So, give the name, it will be ethyl ethanoate. Then they're saying the formula, deduce the formula. The formula will be CH3COO, CH2CH3. Okay. So remember we did this yesterday where I told you that um, if you have like ethanol, which is C2H5, then plus OH, then plus this one should be general formula for carboxylic acid should be N minus 1, then H2N minus 1 COOH. So if it is ETH, because I'm using this because I've not memorized the formula, I just derive using this. So ETH means N is equal to 2, so I'll try to put here C2 minus 1, then H2 times 2 minus 1, then COOH. Then here it will be just C, 2 minus 1 C, then 2 times 2, 4 minus 1, 3, so it will be CH3, then COOH. Okay, so when these are reacting, this loses 3 hydrogen, or loses this part. So now that I've done that one, sorry, let's go back. Now we have done that. Let me rub this because I was driving the formula and I am driving so that you get to start knowing these things very well. So here we are writing CH3 COOH. So now let me now rub this one here so that this one will be now formed. So this one loses this and this one only lose this. So now in forming, this one will be the first one. So it will be CH3 CO. So this one will be the first one up to there, CH3CO. So that one has lost that one. Then this one, you get this O, bring it here, then you get C2H2. Okay, C2H2. H5. I think in this formula there must have been a mistake there. of this part here. Oh, sorry, is correct. Even in this way and this way, they are all correct. Sometimes they can confuse you. It's just that we have taken this C2 here, okay? C2H5. So sometimes this one can also be rewritten in the format like CH3, COO. Then this one C, you give it 2. You say CH2, then CH3. Yeah, you have just scattered this one, you give it 2, this other C, you give it 3. It's the same, this one and this one. Other books, they can even write like CH3, then C, then this OO, they write like O2, then H, sorry, um, they say C, CH2, CH3. So yeah, they just twist them just like that to confuse you. So in answering, this is how it was found. Just to do it so that you know how this was arrived at. Then we move on to B9. Nylon and terylene are polymers. A. What is meant by the term polymer? In answering, we are saying a polymer is a large molecule or macromolecule made up of many repeating smaller units called monomers joined by chemical bonds. Yeah. Then B, apart from being polymers, give one similarity between the two. So apart from being polymers, give one similarity between the two. So we can say both are synthetic polymer, meaning man-made. Then both are condensation polymers. Both are used to make fibers, textile. Okay, so that is it. That. So they said one, but I provided three so that you can understand other similarities. Then C1 says which of the two polymers is a polyester. So we can say terylene is a polyester. Okay. Wow, this nylon is a polyamide. Terylene is a polyester. Nylon is a polyamide because it has an amide link. Okay. So I've mentioned this polyester because it contains an ester link. This is for terylene. Then nylon, it is a polyamide like this. Polyamide because it has an amide link. So yeah, all those I'm giving you as hints so that you understand these things properly. Then we continue to Roman numeral 3. Hence, draw the structure of the polymer showing two repeating units. Encircle any ester link on the chain. So remember terylene, we are saying it is a polyester. So we are going to draw its structure. So this is a structure, and they are saying encircle any ester link on the chain. So this ester link here. Okay. So this group is called an ester linkage. Okay, or chain. Okay. So we move on to the other. Of course, I've remembered if you are finding it hard to follow up organic chemistry, I have actually a book for organic only, notes for organic chemistry only, where I even got this structure, where I explained well. So if you want those, you can get at 20 Wacha. Yes, you are saying, but why saying yes? It is to sell so that you concentrate to read it. If I give it for free, you'll just be sharing it from one person to another without reading. If I sell it to you, you are going to attach value to it. So if you get it, then it will help you very, very much. Let me see if I can show it to you if I have it opened in my tab. Let me see if I have that organic chemistry. Yeah, it's opening. Let's see. Okay, this is the one opening. Okay, I'm sure it has opened. Let me check it. If it has opened. It is opening now. Yeah, so This is the whole organic chemistry prepared by myself. So organic chemistry itself there. So this is organic chemistry itself from the first to the start. When you read this book, you are going to understand organic chemistry very well. Up to the last you have seen. All these things we are talking about, they are found here. Okay, so this is the one I'm saying. It is going at 20 kwacha 36 pages. Then you understand organic chemistry very well. Okay, so this one is good. So yeah, now let's move on with our business. Then if C3 says butene C4H8 is a compound belonging to the alkene series. Butene C4H8 is a compound belonging to the alkene series. So A, they are saying state the general formula for the alkenes. B, draw the displayed formula of the second member of the series. Then what are we saying? C, butene is prepared by cracking petroleum oils. Name the other method by which it may be prepared. Then D, butene can be polymerized. Name the type of polymerization it undergoes. To draw and give the name of the polymer formed from butene. Show at least 3 repeating units. E, butene reacts with steam in the presence of a catalyst to form a colorless compound. A, by 1, name the compound formed. 2, write a balanced chemical equation for the reaction between ethanoic acid and the compound named in E1 above. Include state symbols. So in answering, we'll just start with answering these two. State the general formula of alkenes. So alkenes, the general formula is this one, CnH2n, where n number of carbon atoms. Then 2, draw the displayed formula of the second member of the series. So the second member is actually the first member is ethene, then the second is propene. So propene, the displayed structural formula is this one, C3, 1, 2, 3, and 6 hydrogen. So this is how it can be formed. Okay, then C, they're saying butene is prepared by cracking petroleum oils. Name the other method by which it may be prepared. So other than cracking, it can be prepared by dehydration of alcohols, e.g. hydration of butanol using concentrated sulfuric acid as a catalyst. Okay, so then we move on to the next question, which says C3 butene. Oh, we are done with this. So we are supposed to be here. The butene can be polymerized. 1, name the type of polymerization it undergoes. So the type of polymerization is addition polymerization. Then 2, draw and give the name of the polymer formed from a butene. Show at least 3 repeating units. So in answering, you know, butene is C480 H8. So in answering, because I had no time to draw the repeating unit here, sometimes in a shortcut you can put it like this: 1, 2, 3, 4. These are 4. So it has 1, 2, 3, 4 carbon atoms. So I just wrote it in a shortcut way like this. So this is the shortcut. So now we go to the other one. Butene reacts with, let me just push like that. Butene reacts with steam in the presence of a catalyst to form a colorless compound. 1, name the compound formed. So the compound formed is butanol. So butene reacts with steam. This is hydration. So it forms butanol. In the same, write a balanced chemical equation for the reaction between ethanol and the compound named in this. So ethanoic acid and ethanol, it is a esterification, so um, it will form butyl it will form ethyl butanoate. So now this one, it will be the same one we already showed. This is ethanoic acid plus ethanol. Then it is going to form what we are calling butyl ethanoate plus water. Okay, so we have come to the end of this chemistry revision. I think maybe this one is the last, just as I stated, so that we start looking at other remaining parts. Okay, for now, bye and see you in the next revision.